Hi, welcome back to Missing Chemistry. This is Electron Configuration of Silicon, SI lesson. Well, silicon happens to be the 14th element on the periodic table, so the atomic number, of course, is going to be 14, right? So our atomic mass unit or mass number is going to be 28. Okay, pretty snarly so far. So since the atomic number is 14, we have to have 14 protons. And since silicon's electrically neutral, hey, we're going to have 14 electrons. Well, that's pretty simple. What about the number of neutrons? Well, we go AMU minus protons equals neutrons. Pretty darn cool. Yeah, man. So we go 28 minus 14. All right. That gives me 14 neutrons. Okay, so we're going to put 14 in. Cool deal. Now, before we do the electron configuration, let's look at a couple things. S shell can hold 2 electrons, P shell can hold 6 electrons, the D shell can hold 10 electrons, and the F shell can hold 14 electrons. Also, it's important to know that we're going to use the off-ball principle, which is the diagonal rule. And we'll start at the top of the slide and work our way down like this until we run out of electrons, right? Pretty simple. Okay, let's do the electron configuration. So the electron configuration starts off as 1s2, 2s2. Excitement is just bounding. 2p6, 3s2, 2p6, 3s2. So that gives me 2 and 2 and 6 make 10 plus 2 makes 12. So all we need to do is come down to this 3p right here, and we're going to stop right there, and that's going to be 3p2. Pretty darn snarly, I have to say. Now, what about the orbital notation? Well, that deals with Hund's rule, and we have to remember that in Hund's rule, you have to put an up arrow before you put a down arrow in every suborbit. So 1s only has one suborbit, so we go up arrow, down arrow. Pretty easy, huh? 2s, up arrow, and then down arrow. Then we have 2px, 2py, and then we have 2pz. So we go 1, 2, 3, 4, 5, 6. Then we go 3s, right? 2, up arrow, down arrow. We ran out of room there, so that's okay. We'll just go down here. 3px, 3py, and 3pz. Guys, we still need all 3 of these subshells, because remember that electrons can get excited and they can jump suborbits and they can even jump orbits. So 1, 2. That's easy. Now, what about noble gas notation? All right. Well, the nearest noble gas to silicon, of course, is neon. You can't use argon because that's after silicon, so you have to use neon, right? So you go Ne, and then you got to find the valence shell. The valence shell is that last shell. That's this right here. Here's your valence shell. Okay? So that would make 3s2, 3p2. Now, what about our quantum notation, our last one? All right, so now there are 4 quantum numbers. There's N, L, M, and S. Well, looking at the periodic table, you see that silicon is in the 3rd period, right? So the principal number is going to be 3. Silicon also happens to be in the P block. So that gives us an L value of 1. Silicon happens to be the 2nd element over in the P block. So that tells us the M value is going to be 0. And let's look at this last arrow right there. That last arrow is going up, right? So that tells us that the S spin number is 1/2 positive. Pretty darn snarly. You know what else is pretty amazing? We're done. You guys be snarly, And we'll see you back here at Musin Chemistry.